So chapter 6 is all about percents. And so one of the most basic things you can do with percents is convert them to fractions and to decimals. And that's actually really important with the story problems we're going to see later. This might be one of the most relevant chapters that we do all year. Because if you've ever bought anything, you've paid tax on it. If you've gone out to eat at a sit-down restaurant, you've tipped your waiter or waitress. And if you've ever gone Black Friday shopping, you usually get discounts, right? And so that's all stuff that's incorporated within the percents chapter we're going to talk about. So we'll talk about how you can determine what you're going to pay for an item after the discount and after sales tax and after you tip your waiter and all this extra stuff that we do. So to start off with, let's talk about the word percent. What are all percents out of? Gage? 100. The word percent actually comes from the Latin phrase percentium, which means from 100. So just like a century has 100 years and there's 100 cents in a dollar, the word cent means 100, and so percents are all out of 100. It's easy to compare numbers when they have the same denominator. So to say it's out of 100, 51% means 51 out of 100. What's bigger, 51% or 61%? 61. Yeah, 61 out of 100 is bigger than 51 out of 100. Now what's bigger, 51 out of 99 or 61 out of 105? You really think so? They have different denominators, and so they're not very easy to tell apart. When you have different denominators, it's hard to compare numbers. But since percents are all out of 100, it's really easy to compare percents. So I don't actually know the answer to that question. If you're waiting for me to say which one's bigger, I guess I could use my calculator. What did I say? 51 out of 99? That's 0.1515. So 51.5%. What was the other one I said? 61 out of 105? That's 58%. So it's actually 61 out of 105 that was bigger, barely. Hard to tell when they don't have the same denominator. So what we're going to do here is we're going to have, we have 6 figures. This first figure is a 10 by 10 square. What's 10 times 10? 100 squares, percents are out of 100. I want to know what percent of the square has been shaded in. What percent of this square? Kaylee? How'd you get 60%? Did you count each individual square up to 60?
No.
What did you do?
I took the
Huh. Oh, okay. I gotcha. So you got 60. So I've heard 2 people, and your way is for the most part what I've heard before. I've heard some people say they counted 6 rows. And they knew there were, or sorry, I should say 6 columns, and they knew there was 10 squares in each column. I also had someone tell me, I think this is where Kaylee was starting to go with, they counted the empty rows and knew that was 40, and then just took 40 away from 100. So a couple different ways you could get 60. What about example B? What percent of that square has been shaded in? Gage? 100%. It's entirely shaded in. Don't forget that percents have to have the percent sign after them. So make sure you put the percent sign. Example C, Jude, what percent of this one is colored in, shaded in? 50%, that's right. Every other square, so half of them, means 50%. Looks like a checkerboard, except a checkerboard is 8 by 8, not 10 by 10. Or chess. Chess and checkers are actually played on the same board. But if you played on a 10 by 10 board, that would make chess a lot more interesting. Because you wouldn't have all the, unless you increase the number of pieces. What about example D? Georgia? That's correct, 37%. I've had some students tell me 40% today, and I know why they're saying 40%, but that's too much. So there are 3 rows, and there's 1 column, and if each row and each column has 10, I can see why you'd get 40. However, when you count that column, you can't count those 3 squares twice. So take 40 and subtract away the 3 squares that overlap, and that gives you 37. You okay back there? All right. Does it make sense? Okay. What about E? Caden? 64% is correct. Can you explain how you got that? Okay. 10, 20, 30, 40. 6, 6, 6, 6, 24. Added 24 and 40. Works. Nice job. How did you get it?
I just times 6 by 6, that's 6.
Okay, so you found kind of like what Kaylee did in that other one. You found the number of squares that weren't shaded in. It's a 6 by 6 square, and that's 36. And then what did you do with that 36? Subtract it from 100. Yeah, so different ways you can get your answer. Both of them work very well. What about example F, Calvin? That's right. Yeah, so they took away the squares and they just did columns, but 1/10 is the same as 10 hundredths. And so 10% of the square shaded. All right, let's get into the meat and potatoes of today's lesson. Last year, you guys did this, and you may not remember, and that's why we're going to go over it today. But you converted fractions to decimals to percents. Now, let me remind you, earlier this year, you already converted fractions to decimals. So when you see top divided by bottom, that should sound awfully familiar to you, okay? But since we did this in chapter 2, you were not using calculators at that time. Now you are. So turning a fraction to a decimal should take a lot less time since you can just type it into your calculator. Does everyone have a calculator out on their desk? Okay. So once I've got my decimal, fraction to decimal, I have to move the decimal 2 places in what direction? Kaylee? To the right. To turn a decimal into a percent, move the decimal 2 places to the right. That is because all percents are bigger than their equivalent decimals. They're bigger, so you move it to the right. The reason you move it twice is because every time you move a decimal point, you're timesing by 10. So what happens if you do 10 times 10? That's 100, and what are percents out of? Right, that's why we have to move it twice. So it doesn't say move it to the end, or just move it once. It's always twice, which means sometimes we have to add extra zeros. Let's practice that right here. So here are the steps again. To go from fraction to decimal, I'm going to do top divided by bottom. So in this first example, my fraction is 2/5. Now don't worry about the 1 in front of the fraction. That 1 in front of the fraction is just a 1 that goes in front of the decimal point. So really no issue there. What is 2/5 as a decimal? Cole? 4/10. Okay, so say 0.4. Okay, which is the exact same as 4/10. Not everybody recognizes it that way though, but that's actually the long way of saying it, and that's correct. It's even better. So 2/5 might be a fraction you memorized last year. Mr. Tuberty and Mr. Miller are really good about having you guys do your 5ths and your 4ths, your 10ths, your halves, right? You might remember 2/5. If you don't, top divided by bottom, 2 divided by 5 gives you 0.4. So you just add that onto the 1 that you already have. Now to turn it into a percent, we're going to take the decimal point and move it 2 spots to the right, which means we have to add what digit right there? A 0. So our percent answer is going to be 140%. Now, percents, even though they're out of 100, can be bigger than 100. If I told you that my stock grew 140%, that means it exceeded the expectation I would have had for it. It more than doubled in size, and that's good, right? So it's okay for percents to be bigger than 100. Yes. What is the?
It's like they're describing
Just like 5/3 is bigger than 1. You're right. The fifth, I know what you're talking about now. Yeah, the fifth third bank which is interesting because my mortgage goes through Fifth Third Bank and as of January, as of this month. But yeah, it's 5/3, which is bigger than 100% because 3/3 would be exactly 100%. So you're right. Yeah, it's okay to have percents that are bigger than 100. What about 5/8? Ella, can you tell me what 5 divided by 8 is? That's right, 0.625. So again, Ella didn't use some sort of, sorcery or witchcraft to get her answer. She simply divided top by bottom. Now, this is where the sorcery comes in, Navion. What are you going to get when you move the decimal 2 spots to the right? What's your new percent going to be? That's right, 62.5. And it's okay to have a have a decimal in your percent. That's okay. Happens more than you think it might, actually. Calvin, you all right over there? Yeah. Last one, 2/3. Avery, what is 2 divided by 3? That's right, 0.6 repeating. And remember that your calculator is going to probably put a 7 at the end. That's because your calculator ran out of room because it goes on forever and they just rounded it. But it really is 0.6 repeating. So to turn that into a percent, I still have to move the decimal 2 spots to the right. Landon, when I move the decimal 2 spots to the right, what does that give me? Not 60. What do I have to put in that slot right there? Not a 0. Yes, a 6. Because the 6 is repeating, I have to put another 6 right there. Unlike the one before where the 4 wasn't repeating, I can just put a 0 right there. I have to put another 6 here. So this is going to be 66. However, the 6 keeps going. So put a decimal point, put another 6, and then we can put a line over it. 66.6 repeating percent. Don't just say that it's 66% because it's actually closer to 67%. You are not legally allowed to put repeating bars over any other numbers but decimals. So I see some people that will write this. That's not a number. That's illegal. They will arrest you for that.
No, wait, what?
They'll arrest you. Yep. 2 years of probation. Got to wear the ankle bracelet. Yep. So you're better off just writing it as 66.6 repeating. You can put repeating bars over decimals only. Now, this answer, although it is correct, will be counted incorrect on big ideas. Why? Jack? Yes, they don't have a repeating bar. So when you just type in 66.6, that is not the same as 66.6 repeating. It will count it wrong. There's no repeating bar. So on big ideas, you will have to rewrite it as a mixed number. We've done this before. We just said that 0.6 repeating was the same as 2/3. So after you get the 66, just replace that 0.6 repeating with the 2/3, and you have this mixed number. 66 2/3%. It will accept that answer. 2/3 is 0.6 repeating, or 66 2/3%. 1/3 is 0.3 repeating. That's our other repeating decimal, and that's 33 1/3%. Okay. Other than the repeating decimal part, this is probably the easiest method to go from fraction to percent, because I can use my calculator to divide and just mental math, slide the decimal 2 spots to the right. This second way is a little bit more difficult. Now I'm going to ask you to go from percent backwards to fraction. And the part that, obviously I'm going to move the decimal 2 spots in the opposite direction. That's not the hard part I'm talking about. So I'm going to move the decimal 2 spots to the left, obviously. That's not what's difficult. What's difficult is I have to take that decimal, put it over its place value. And what do all fractions have to be? Simplified or reduced. Yeah, I need to reduce it. And that's what can be a little bit more time consuming. I wouldn't say it's difficult, just a little bit more time consuming. So again, if they're asking you to go backwards from percent to fraction, move the decimal back 2 spots back to the left, and then write that decimal over its place value. Your place values are the tenths column, the hundredths column, or the thousandths column. Now it continues. What's after 1,000? The 10,000th column, and then the 100,000, the millionth, and so on and so forth. We're not going to exceed that. We're probably just going to need to know the first 3 decimal places for this section. All right. So I'm supposed to move the decimal 2 places to the left. However, there is no decimal point here. Where is it located? At the back. Yes. So 90% is actually the same as 90 point nothing. Now that I've got my decimal point, and all the decimal points for these numbers, if they're not listed, it's because they're hiding at the back. All of them have to move 2 spots to the left. 1, 2, 1, 2, 1, 2. All right, Jude, what is 90% as a decimal then?
0.9.
Okay. Thomas, what's 2.7? Sorry. Thomas, what's 4% as a decimal? Nope. No. So you have to move it twice, right? That means I have to put a 0 right there. So go ahead and say it for me. So you're putting the 0 here, which is okay, but I still need a 0 there. So 0. There you go. Yeah, 0.04. And I don't need the 0 in front of the decimal point, just like Jude didn't give me the 0 in front of the 0.9, but I do need the 0 in front of the 4 here. Okay, it's really important that I put it right there. So 0.04 is fine. Now I'm going to take my decimal and write it over its place value. What place value, Riley, is the 9 sitting in? That's right. So I write 9 over 10. 1 decimal place, 1 0. 2 decimal places, hundredths column, 2 zeros. 3 decimal places, 3 zeros. That's not a coincidence. That's how it works. Natalie, how many decimal places do I have for the second number, 2.75? 2. So I'm going to write, first of all, before I do that, the 2 that's in front of the decimal point is just going to go in front of the fraction, okay? Just like before. But because 75 has 2 decimal places, as Natalie just said, I need to write that over 100. We are going to reduce it, yes. You actually go ahead. If you already know what it reduces to, go ahead. And then the last one here, 0.04. Georgia, what do I have to write the 4 over? That's right, 4 over 100. I don't need to write 0.4 over 100. Nobody writes 0.4, just write 4. But it still has 2 decimal places, so I put it over 100. Now, Cole made a good point. All of our fractions have to be reduced. Does 9/10 reduce? No. Remember, it will reduce if there's a number that can go into the top number that also can go into the bottom number. So if they're divisible by the same value. Cole, why did you say 3/4? What number were you reducing by into 75 and 100? Like quarters, yeah. So if you take 25 out of 75, and if you take 25 out of 100, that's going to give you a reduced mixed number. It's a lot nicer to work with, 2 3/4. Okay, so ignore that bell. We'll dismiss here in about 10 minutes for your passing period and then your homework time. What about 4 100ths? What's that going to reduce to, Gage? That's right. What did you reduce by? Top number reduces by 4. Bottom number reduces by 4. And you get 1/25. Now, if you didn't know that 4 went into 100, you could have reduced by 2. You would have gotten 2/50, and 2/50 turns into 1/25. Now, before we take our restroom break, the other classes got to work on this chart for about 6 minutes or so. So this is a FDP chart, fraction decimal percent. What I need you guys to do, and I'm going to let you work with a partner on this, is I want you to fill in this chart with all the missing blanks filled in. Some rows only have 1 missing blank. So 3/4 is the same as 75%. I need to know what decimal it is. You can either do top divided by bottom, or you can move the decimal backwards twice, whatever you prefer. This one also has 1, so 45% is the same as 0.45. I need to know what reduced fraction it is. And then the rest doesn't have 2 missing blanks. It takes a little bit longer to do. So I'm going to give you guys about 6 minutes from now to see how much of this chart you can fill in. And if you don't finish it in the 6 minutes, you can come back after break and you can work on it then. Okay, but 6 minutes we'll take our passing here, 6 or 7 minutes. So go ahead and get with a partner. If you want to work alone, you can, or you can work with a partner and see how many of these you can fill in.
All right, following students, please come to the office. Gabriella, good.
Remember, all your fractions have to be reduced. Go ahead and move around.